Hi, thank you for watching part 1 of 2 of my explanation of glycolysis and gluconeogenesis. Now, glycolysis is the degradation of glucose, a 6-carbon molecule, into 2 3-carbon molecules of pyruvate. But gluconeogenesis, the opposite of that. You're creating glucose, you're not breaking it down. Now, one would think that the two pathways would be just reciprocals of each other, but they're not. They use different enzymes and they're slightly different, although some of the substituents are the same. So without further ado, I have my marker board here. I'm going to walk you through the entire process of glycolysis, enzymes, ATPs to ADPs, everything. So obviously, fix the camera a little bit, we start off with glucose. Glucose is then changed with the help of hexokinase. And we're going to take an ATP, we'll go to ADP, because we're going to add a phosphate group to glucose. So the hexokinase will change this to glucose 6-phosphate. Now, glucose 6-phosphate is, with the help of phosphoglucoisomerase, is going to change to fructose 6-phosphate. But notice here we have the double arrows, it's reversible. So the phosphoglucoisomerase going to go to fructose 6-phosphate. Now, for the sake of brevity, if you're doing this alone at home and you're just practicing, feel free to write G6P, F6P, as long as you know what it is. But I'm not going to have any shortcuts here. I'm going to do everything by the book, sort of. Like I want everyone to understand what I'm doing. So fructose 6-phosphate with another irreversible reaction with phosphofructokinase. Notice the arrows each time, whether they're reversible or not. Also, we're going to have another ATP going to ADP because we're adding another phosphate group to fructose 6-phosphate, and we're making it 1,6-fructo. I'm sorry, fructo 1,6-bisphosphate. Again, feel free to indulge in the whole brevity thing. I'm just writing it all out. Then we have another reversible, another enzyme, aldolase. We're going to have glyceraldehyde 3-phosphate. It seems I've run out of space, so let everyone copy that down, give a couple seconds, or you can just pause the video. I'm going to erase the board and start from the top. Alright, so we're going to use another enzyme. This is reversible. Glyceraldehyde 3-phosphodehydrogenase. And in this reaction, we're going to have an inorganic phosphate plus NAD plus, it's going to go to NADH. Okay? Now, this next part, it's important to note that up until now, we've been dealing with a 6-carbon molecule. But this reaction here, this enzyme, the glyceraldehyde 3-phosphodehydrogenase, has cleaved the molecule into 2 3-carbon molecules. So we're going to put a 2 in X brackets. Remind us of that. So everything after this is multiplied by 2. So this enzyme is going to cleave, and we're going to get 2 molecules of 1,3-bisphosphoglycerate. Alright, so as the name implies, again, we're going to have a phosphate group on carbon 1 and 3 of the glycerate. So from this, we have a irreversible reaction with phosphoglycerate kinase. This time we're taking away a phosphate group, so we're going to go from an ADP to ATP. So from this we're going to get 3-phosphoglycerate. So we lost the phosphate on carbon 1. So 3-phosphoglycerate is going to, with the help of the enzyme phosphoglycerate mutase, it's going to actually change the phosphate group from carbon 3 to carbon 2. So what do we have? 2-phosphoglycerate. I apologize if my handwriting is not that great. But after this, we're going to have another enzyme, enolase. We're going to lose a water molecule there. And we're going to be left with phosphophenylpyruvate. Sorry about this. Phosphophenylpyruvate. If you find a better way to abbreviate it, please feel free. It's just for the sake of the video, I'm not abbreviating anything. So phosphophenylpyruvate with an irreversible reaction here. I'm going to go to pyruvate kinase. We're going to have an ADP going to an ATP. So if you notice, we used 2 ATPs in the beginning that went to ADP, and then later on we used 2 ADPs to go to ATP. So the net reaction for using ATPs is 0. We're not losing ATP here in the long run of things. So what does this give you? Final product, pyruvate. And it's important to note that everything from this point on, you have 2 molecules of everything. So in the parenthesis there. Sorry, it's a very bad bracket. But thank you for watching. Next video, we're going to be doing the opposite, which is gluconeogenesis. And hopefully there'll be many more biochemistry videos to follow. It's always been a passion of mine, along with organic chemistry and cell biology. So hopefully there'll be a first of many educational biofilms. Thank you for watching.